Good morning and once again welcome to my YouTube channel Pearson and Excel International Maths by Mr. Kamotho. And today I just want to respond a question from a student, Hatim from MSB Nairobi, and he's requesting me to sketch on the same set of axes the graphs shown below. And you realize that if you take like the first one, which is y is equals to x 4 minus x, you will realize that it is completely finalized into two brackets. And if you are to solve the equation y is equals to 0, whereby we need to get the critical values when y is equals to 0, or rather the x-axis intercept, we would take each of these brackets to be equals to 0, because when we have two brackets multiplied out and the product is a 0, then it follows that one of the bracket is 0, or rather we could have x is equals to 0 or 4 minus x is equals to 0. And if this is true, then you realize that x is equals to 4. So those are the critical values before we even come to the nature of the graph. So as we plot this, then we have the axis, the y-axis, we have the x-axis, and the critical value is x is equals to 0, that is the x-axis intercept, and x is equals to, let's say, 4. But now you have to know the nature of the graph. If you attempt now to open this bracket, you will realize that y is equals to minus x squared minus, you're going to have 4x minus x squared, that is plus 4x. The nature of a is less than 0, and when a is less than 0, then we have n-shaped graph. We have n-shaped graph, and we are going to have a graph that looks like this. When that is true, we could also get this shape by assuming values of x which are less than 0, which is like -1. Let's just put it over there. 4 minus 1, and then you're talking about -1 multiplied by 5 becomes -5. So it is justified as x continues to be less than 0, then you can see as x approaches negative infinity, y also approaches negative infinity. We have seen that nature. If we would want to take another value of x which is probably beyond the upper limit, which is 4, and let's say x is going to be 5, 5 multiplied by 4 minus 5, which is 5 times minus 1. Obviously, this is -1. So you would see as x approaches positive infinity, y approaches negative infinity. So as x continues to be to increase, y continues to decrease. So that is the nature of the graph, and you can now name this equation y is equals to x 4 minus x. If we come to part B of the question, I would talk of y is equals to x squared, and I want to break x squared into 2x times x minus 7 minus x, and again consider this one to be finalized brackets. And even as I attempt to solve the equation y is equals to 0, in an attempt to get the critical values, you can see if three factors are multiplied and the product is a 0, then it means each one of them can be 0. And at that point, x can be 0, x can be 0 because of these two repeated roots, x can be 0. And of course, 7 minus x can be 0. And this tells us x can be 7 for that matter. So in the same set of axes, I would want to talk about this is 7, this is 0, and this is 0. So there is the turning point when x is equals to 0. It's a turning point because it is a repeated root. And we would want now to examine what happens when x continues as x approaches negative infinity. How does y behave? And I want to look at x being equals to -1. And I want to consider -1 here. So -1 multiplied by -1 multiplied by 7 minus -1. 7 minus -1 means 7 plus 1, which is an 8. Already this one is a positive. Negative times a negative is a positive. So we have 8. So as x approaches negative infinity, y approaches infinity, positive infinity. So the next graph you're going to have, as x approaches negative infinity, y approaches positive infinity. Of course, we are very much convinced this one is a turning point. So we will treat it like that. But let's take when x is as x approaches positive infinity, how does y behave? So the highest value of x is 7. So let us take one step beyond 7 and let's take x to be 8. Let's talk about 8 multiplied by 8 multiplied by 7 minus 8, which is -1. This is 64 times -1, which is -64. So as x approaches infinity, y approaches negative infinity. And it goes without saying that way is, so we will have as x approaches negative infinity, y approaches positive infinity. So, and this is the turning point. So we will have something that looks like this, a graph that looks like this, and then behaves that way, and then behaves that way. So note 0 is the turning point, and therefore it has to touch and leave, and then drop at x being equals to 7. And then as x becomes positive infinity, y continues to be a small value. So that is it. You can see we have two points of intersection. Point x is equal, when x is equal to 0, the two graphs intersect, and when x is something else between 0 and 4, the two graphs intersect. You could be asked to solve to find this particular coordinates, and you will only be able to say that y1 is equals to y2, y1 is equals to y2, and therefore this function is equals to this function at the point of intersection. So again, you name this graph and call it y is equals to x squared 7 minus x. And that is just like it. I hope, Hatim, you have been assisted. Anytime you have a question, let me know. Let us work together. All right.